Many developers love using command line tools for their daily tasks, at least I do. It's fun, they're usually more performant, and sometimes it's just a necessity. For example, there are many desktop applications to work with Git, though I believe that many programmers still use Git CLI as it's faster, it's the same on all environments, be it your dev machine or server. And there are two main flavors of CLIs. One is imperative command-based CLIs, such as git again or kubectl, where you define everything in a prompt and provide flags and arguments. And the second one is so-called terminal apps or terminal UI, which is more interactive and basically a whole application that runs in your terminal. For example, there is this great terminal UI called CLX that lets you read Hypernews in your terminal, where you can browse the articles, open them and read them. Developing CLIs and terminal apps in Go is really fun, and there are really a lot of packages out there to make it so. For example, for developing command-based imperative CLIs, you can use something like Cobra from Steve Francia, which was actually used to build famous CLIs such as kubectl, GitHub, Hugo, and others. It's kind of a framework of its own, where you define the list of commands, possible flags, help command, etc. And when it comes to developing more interactive terminal apps in Go, there is a really great package out there called Bubble Tea from Charm that lets you develop really interactive and beautiful terminal apps. It's also used commonly with other libraries from Charm, such as Bubbles or lipgloss. So Bubbles is a components library and lipgloss is a styling library or package. For example, the command that I showed you previously, CLX, it was built using Bubble Tea. Bubble Tea is based on the Elm architecture, which makes it really straightforward for developing terminal apps. A Bubble Tea program contains a model which describes the state of our application. And there are two simple methods on this model. One is view and another one is update. So view method would basically render our model as is, in our case render it to the terminal, and then the terminal will send some events to this model, we will update it accordingly and call the view again. And yeah, Bubble Tea takes care of everything, re-rendering, sending these events, and so on. And so in this video, I want to show you how to build terminal applications using Bubble Tea. For example, we'll build a note-taking application, so you can list your notes, create new notes, edit notes. We'll have some sort of storage. We'll use SQLite for that. And yeah, that's it. So let's get started. Cool. So let's start scaffolding our application. So we'll initialize the Go module called TUI. As I mentioned before, each Bubble Tea program needs a model that represents your application state. So let's start by defining this model. So I'll create a model.go file, and then we'll do some scaffolding there as well. Cool, so let's start defining our model struct. So we can call it model. And imagine our application can be in multiple states. So we can list the nodes, then when we want to create a new node, there will be another state, and when we want to put a body of our node, there will be another state. So at the moment, I think of 3 states. Maybe we can enumerate them here. So, for example, list state, let's even call it list view. And then we'll do the rest, title view, and then I'll call it body view. So since we are working with nodes, we want to save them somewhere, and I mentioned that I'll be using SQLite for that. I don't have this interface yet, but I imagine in the future it could be store here. Then what else? What's cool about Bubble Tea that you can embed other models in your own model. So for example, in the future we'll be using bubbles components such as Textinput, Textarea. So I can do here Textarea, I believe it's .model, so we'll uncomment it later. And we will do have multiple fields here. So because we want to know which is the current node in the list that we are viewing, etc., etc. So I'll fill it later. Now let's create a, for example, new model function that will accept the store. And we don't have store interface defined yet, but it will return our model. For now, we don't do much here, so we just return model and just set the default view, which is a list view. So we can do state list view, right? Let me just remove that for a second, and then we'll add it later, right? In Bubble-T, your model needs to implement 3 methods. One would be init, then view, then update. So we won't do much in init, but we still need to have that. So init, and it will return t.cmd. So for example, if you want to do some initial I/O, but let's first import our Bubble-T here. We don't do anything here yet, so we can just return nil. And actually, this function will be always return nil in our case because we don't do anything initially. I think we can load our current nodes from SQLite directly in new model function, so we'll leave it empty for now. Now we need update, so we can keep it here as well. So our update function receives a message, which is t.message, and it returns an updated model and the command, so tcmd. Right, so in this function, we'll receive a key, which will be, let's say, a key pressing, some other events, then we'll update our model and return it. Then Bubble-T will call a view method, which we still need to define, and then render everything to our terminal. So we'll still come back to this function, but for now, let's just return our existing model without any modifications and empty command. All right, now I also mentioned that we need a view method, so I'll do it in a separate file. And we need on our model to create a view function. And view function is really simple, so it just takes the model and should return a string. So let's do something like that, right? So we have all the methods now for our application to work with Bubble-T. We still have a lot to implement, obviously, especially in the methods update and view. We also need to implement the store. We need to use other components for inputs and text area. But let's compile our application as is and see how it works. Oh, and obviously we still need a main.go file to do so. So that's what we forgot. So package main. Then we also need to import our Bubble-T here. Here we can initialize our model using our new model function. Then I believe it's t.new program. With model, and then we can do p.run, I believe. And let's do something like that. So I'll still need to do go-mod init. And we can do log, maybe fatal. To run TUI and our error, right? Cool. Now let me run go-mod tidy to download the packages. And now we can see if it works at all. So go build maybe members or nodes and do like that and run our nodes. Awesome. So it reaches the view method. Obviously, if we type now anything, it doesn't react. There are no key bindings yet. So before actually implementing anything in Bubble-T, It's clear that we need a store for saving our nodes, listing the nodes. So let's start with creating the store that will use SQLite. So we'll have first the node struct, right? So just to see how a node may look like. And I want to do it really simple for this exercise. So maybe some ID, then a title and node body, which is a, so for title we use the text input and then for body text area, right? Now let's define our store. We could use interfaces, so then it will be easier to switch to other backends or to desks. But for this exercise, I'll just create the direct store, which will hold the SQL, I believe it's SQLDB connection. We probably just need a single table for nodes, so with ID, title, and body, and we can make sure that this table is there in some sort of init function. So let's do on the store an init function that may return an error, and then we can initialize our as.connection error with SQL. It's open SQLite tree and the name of our database file. So let's do something like nodesdb. So if error, return it. Otherwise, here we need to create this table. And also to work with SQLite, we need to import the drivers, so something like that. And now we can start our, let's say, migration, right? So create table statement. Let's say create table if not exists nodes. So we want to make sure that, I don't know, if we run it twice, it won't try to create this table again. Cool, now we need, if it's ID, integer, not null, and let's make it a primary key. We also need a title and, oops, and a body. And we can try to run it. So I believe it's as connection.exec. Otherwise, all good, return nil. Cool. Okay, so now we need few methods to probably list all the nodes and then to save the current node, or maybe to create one. So we can create an update, we can group into a single upsert function, but let's start first with get nodes, right? So store of get nodes, no arguments, right, something like that, and then we'll also do save node, kind of, it will be given a node, and then it will return an error. All right, so let's see the table. Great. By the way, I think we need a comma here. Cool, I think we can start here with rows, error equal, I don't know, I think it's scon.query, and then, so no pagination, nothing we can do, select all from nodes. Should also not forget to close our rows. So at the end of the function, like that. And now let's just loop over the rows. Write an array of nodes, and then for, I believe it's rows dot next, we can create so we do very simple here, and then rows dot scan destination, right? So node ID, node title, node body. So we just assume here that everything is not nullable per our schema, so you don't need to check for null values. So that should work like that. And then simply add it to our list of nodes. So node cool. So we have the list of nodes function. Now let's save that. And also I mentioned that I want to have the same function for insert and update. So you can always do upsert, and you just can do it by checking the ID. So for example, if ID is empty, then we just generate the ID, right? So let's do the following. If node dot IDs equals 0, then, and we can do some pseudo random. Obviously it's not bad for this exercise, it's just enough. So maybe time now to see, then Unix, I believe, or maybe Unix Nano. So that's better. Cool, let's do Unix Nano. Cool, now let's write our upsert query, which would be insert into nodes, which columns are ID, title, body. So values. So we can do on conflict, I believe ID. So we'll do update, and we could do set. So just update the title. So what's that? So SQLite, that's how you do, kind of how you get the current values, and then body. Cool. Now, all right, we will do the following. So, all right, this connection dot exec upsert query, then all the fields, right? So node ID, node title, node body. Error. Return nil. Cool. So I believe, let me just double check. Insert into nodes, on ID, and so these functions will be called then from our model when we do specific actions. So now it's finally the time to get there, right? Get nodes. Awesome. Now let's update our model. So that's the store, and then maybe also, so maybe let's just do it a pointer here, right? And also pass it to our model, right? So store. It's cool. Now let's go to main.go file. Yeah. So storage, something like that. Let's initialize our store. So it's not as right, it's store dot init. You can do similar, just enable to init store. Otherwise, yeah, we just pass it to our model like that. Awesome. So now we have our store. We can also save locally the list of nodes. So that will be showing them in our view method. Maybe we'll need later a current node that we edit. And since we also, so in the list view, we should be able to kind of click up and down and then kind of go between the nodes. So we can also store the current index, right? So maybe list index. In our new model, that's actually so when we create the model, we can fetch the current nodes from SQLite table. So we can do it nodes, for example, error equal store dot get nodes. Check for this error. Maybe for simplicity, just Ctrl F. Enable to get nodes. And if all good, so yeah, just add them here, right? Nodes. So list index, yeah, can be 0, current node could be just of empty value. Awesome, now let's move to the fun part, the update function. So that's where we should process the key events. So on the list view, what we can do, we can obviously exit the application, we can create a new node, and then we can go between the nodes, and then maybe press enter and be able to edit the node. So as you can see, we have different messages that can come to our update function. We are at the moment are interested only in key presence. So let's just do maybe the simple switch here by checking the type of the message. And since we're only interested in key presence, that would be t.key message. Exactly. Now we can also figure out which key is that. So we can do key is equal message string, and here we will see things like up, down, Control C, Q, etc. So now we need to check them. Since our key bindings are specific for each state, so in list view we have one set of key bindings like Q and in the edit view we'll have another. So we can do the switch first on the state. So switch m.state, and then let's say list view, right? And now inside of this case, let's do a switch by key. So I know that there is a kind of a lot of switches here, but they're just to separate key bindings for each state, right? So switch key, and then so what we'll have just a quit, right? And in quit, so we can do return directly here. So return our model, and then there is a specific command tquit. So that will just quit our application, right? Now we can do n key binding, for example, for creating a new node. So, and here we do the model update. So when you press n, what happens? First, we need to change the state. So state will be now in the title view. So when we press n, I want to create a new node, it will ask to give us a title of this node. And then probably we need to show the input here, so we'll do it later. Now we can do listings, right? So up and k. So this just updates the index. We can check if m is greater than 0, so we don't get out of the list. So do something like that. Now it will be down, or let's say j. So if so we also don't want to go out of this list. Now, if we select any node and we press enter, what happens is that, so first of all, maybe we set a current node. So we do that, and then we also change the state, right? So state becomes body view. So we select a specific node and we want to modify it. And yeah, we also need to show text area here afterwards. Cool, so that's our list view, right? So some key presence, it updates the model. I already mentioned a few times that we'll need text input and text area, and I have some comments here, so why not adding them at the moment? So we can now use the bubbles library or package with components, and there's a text input as well as text area. And what's cool here that they have their own models, and they could be just embedded into our application model. So we can do text area.model and then text input.model. But let's give them names. So text area and then text input. Awesome. What we also need to do is to actually initialize them. So text area would be text area.new, and then the same for text input. Now let me just run gomod tidy. So we have these packages, SQLite tree as well. So since our model now has other models embedded and we have our update function, we should kind of pass this update to this text area and text input as well. So whenever our update function is called, we should call text area.update and text input.update. And that returns the list of, it returns the command as well, right? So I believe that's, let's say, text input first.update. This is actually wrong. So it returns, similar to our update, it returns the model. So it updates the mtext input, that's our model, and command. So, all right, let's do the following. t.cmd and do something like this, right? And the same we do for text area, right? So let's do text area here, text area here. Yes, so now we need to return the CMD. We can also batch, so because we have multiple commands, let's also batch them, and I'll show you. Let's do CMDs, multiple commands, something like that, and then let's append. So CMDs, CMD, and then the same for text area. And now at the end of this function, so remember we've been returning nil, we can now actually return this batched execution. So do t.batch and multiple CMDs. So we have CMDs and just unpack them here. Cool. So what happens, right? Our update function is called, we have text inputs and text area, and then we call update on them as well. Awesome. Now we can continue somewhere here before we get to the view functionality. So let's just figure out how to do all of that here. So we need to show the input when we click N. And actually, let's do this before we change the state to make sure once we change it, everything is ready. So we can do text input, maybe clear the value if there is any. We can focus on that because in the future we'll be hiding that using the blur method. And we can also reset the current node if there is any. So maybe current node, just empty node, and then we change the state to the title view. And now in the body view, we can do something similar, but with our text area, right? So we already set the current node. We can do text area. So that's set value. So because we are editing here, we need to provide the kind of existing body. So current node dot body. What else can we do? Set text area. We can also probably call focus as well. And let me see. All right, that's cursor end. Cool, and I believe that will be enough for the update function of the list view. Awesome. Let's now go to our view function, which is currently quite empty. And here I mentioned that we can also use lipgloss for styling, kind of to set any backgrounds, any other cool stuff. So let's just import this in the beginning, and then maybe also define some styles, right? So let's print the name of our application at the top, and then everything else depending on the state. So this notes app, I want it to be styled a little bit. So you can do app name style. I think it's lipgloss. So actually it's lipgloss. And then I believe new style. And yeah, there are multiple functions here. Let's see if we can set the background. So do lipgloss. If it's color. Something like that. We can also set maybe some padding here. Yeah, let's just see if that works. So I'll also change, just return to have our string, and then app name style, and there's a function called render. So we'll do render, and yeah, notes app. Let's add some new lines here, and then do some if statements. So if we have our model, right? So if mState equals list view, so we'll do our, so here we'll iterate over the nodes, right? Update our s variable, and then just return s, right? And so what we can do here, we can first of all tell the user what keys can they press. So let's say m new node q quit. Here we can just iterate over the nodes. Let's define some prefix so users see which current node is active. So maybe by default prefix is empty. And then if I is equal to m.list index, can do prefix equal, for example, this symbol, right? I'm not sure, maybe make it a space. So what will be showing for each node, right? We can do this prefix plus node dot title, maybe kind of separator, and do n dot body. The body can be long, so maybe let's do some short body. let's also replace probably new lines, right? So let's replace all. What's that? Body will place it spaces, and then also let's say if not short body, say more than 30, to short body equal body something like that, and then short body here. So in this line we haven't used any styles yet, so maybe also let's add maybe some faint color for the body, and then title maybe as is, and then maybe some color for the prefix. Cool, so maybe let's create more styles here. Faint, maybe foreground, say 245, and I believe there is one faint, true. And for the list, let's do it enumerator style. Yeah, let's just use some various colors. Maybe do some margin right, so it's visually pleasing. And yeah, let's go here. So what's that? Numerator style, dot render prefix, short body, we do faint style, dot render, short body, and also some new lines. So we can also do and we can also do faint render for the key bindings. Awesome. So we did our view functionality for the list state, right? So we loop over the nodes, we provide some key bindings, we return the string. Let me go into the model. So we currently don't do anything for the state title view and body view, so that will be done later. Though this functionality is good, we just need to add it to the view. But let's see how the application works as is at the moment. Awesome, now let's execute our application. Cool, we have a nice app name. Here between the app name and the key bindings, we would see actually the list of nodes, but we don't have them in our database. I haven't seen any errors, so that's probably fine, they're just not there. Let's see, press N. Obviously, it doesn't work because the title view is not yet implemented. But if we press Q, yeah, we should be able to exit our application. Cool. This part works well. Now let's continue to creating the title and saving it into the database. So since we are already setting the state to title view, we can start with the view function and actually just render this title. So we can type our node title, and yeah, so we'll just do it here. So it's title view, right? We can append to as node title. Then since we have our model text input, it also has the view method on it. So we can append to our returning string text input dot view. So same function, and maybe also and some key bindings, similar to what we did here, though different keys. And what we'll do, so if you press enter, that will be safe. And then, so we don't want to quit on Q because Q is kind of a valid character in the title. So maybe we'll do escape, and that would be discard. And then you quit only from the list view. So the view part, I believe that's enough. Now let's go to our model.go file. Right, so we press N, we go there. Now let's do similar for, so what we did after this switch, we do case title view, right? And also we do switch, similar here. But so we have enter, and then we have escape. So if you press escape here, nothing special happens. We just change the state to a list view. So we kind of back where we were. Now, if you press enter, let's first validate if the title is actually set. So maybe let's get the title. I believe it's textinput dot value. Also, if title is not empty, then so we already have the current node. We can do current node title equal title. Then we can do some similar functionality with Textarea. So because now we need to open the Textarea view, though there is no node body yet, so that will be empty. We focus, we go to the end, and then we change the state to the body view. Body view. Cool. So we still don't write anything into the database, so we collect the title and then proceed to the body view. So now we can reach the body view. Let's go back to view.go file and also render our Textarea, right? So that will be body view. Maybe it's node text area. It's can view. Then a little bit different. So we can still do, right? It's escape, not SQ. So escape discard. And let's do Control S. That would save our node. Awesome. Now let's go back to our model and do kind of a similar thing, but for the body view. Now, so we wanted to save on Control S and exactly on escape. Yeah, we can still go back to the list view, so this part is good. Let's do body equal text area value, and we can append it, or I mean set on our current node. So we can do m.current node body equals body. Maybe let's not check it. If it's empty, then it's empty. So don't do anything here, right? Yeah, so here's where we call our store. Let's do if that was our m.store dot save node m current node. So you see, we can come to this place on Control S for existing node or for a new one. So, and then we call our upsert function here, and in one case we will have ID, in other case ID is 0. What we can do in case of error, right? We can just maybe quit from the application. That's one approach, ideally. So maybe let's set to do handle error better, right? Remember, on our state, we also have the nodes slice. So that's kind of the local representation or a list of nodes from the database. So when you enter the list, we don't fetch it every time. And it can update at the moment only when you edit the node, so or edit the new one. So let's just update our list of nodes here. We'll do m nodes store get nodes, just to make sure that we always have the latest cool. And then if everything goes well, right? So if we save the node, what can we do? We can probably just reset the node if it's actually needed, just in case. Node, and then go back to the list view. And then we should be able to see our created or updated node. Great, so if we have a look at everything, we have our 3 states. For each state, we manage the key bindings, so that would be for the list view. And we still have to test all of that because we didn't have the nodes list, so that's what I want to do now. We have title view. We can kind of create the title, then proceed to the body view, enter the node, click Ctrl S, and then the node will be saved. Or you can also come here from the editing view. So just list the nodes, press enter, and then go there. So, and then also, because we use SQLite, when you exit the application, then run it again, you should be able to see the list of nodes. I can actually already see that nodes DB is already there, so that's all good. Yeah, so let's build this application and then see how it works. Cool, so we've already seen it. Now let's try to create a new node. So I press N. That's that's the view of the text input. If I don't enter anything, it doesn't work. Let's do test 1. Press enter. We go to the body. Let's say it's it's a node, right? Something like that. And now we press Ctrl S. It saves. Just let's do another one. Something else. Ctrl S. It saves. Yeah, we can go between them. So I press up and down or J and K. I quit the application. I start again, and I see my nodes. Now, what we want to test also, if I choose a node, I press enter. Yeah, I can edit it. Ctrl S. Right, it updates everything. We quit. We just confirm it again. Awesome. So yeah, that's a node-taking application in your terminal that uses SQLite. Another small thing I wanted to mention is that it could be sometimes hard to debug your bubble T programs because it takes control of your std out. But you can overcome this by logging into external files or using external debuggers like Delve. Otherwise, it's really cool and fun to develop terminal apps using bubble T and Bubble's components and lipgloss. The API is really well thought out. I will leave the full source code in the description so you can run it or customize it yourself. And that's it for today. Thanks, folks. Bye.